This is quite a long question. The first part's fairly straightforward. We're asked to find the distance AB, and we're given a formula that tells us the distance from A, and we know at B the time is 40, so the distance AB, we just need to sub 40 into that equation, and we get 680 meters. So that's a nice easy one marker for A. Right then, part B shows that the train travels with constant acceleration. So we've got a distance formula, and if we take that formula and differentiate that, get the ds by dt, we can find the velocity. So that's nice and easy. That's 25 minus 0.4 t. And then if we differentiate a second time to find the acceleration, the rate of change of velocity with respect to time, we get minus 0.4 meters per second. So constant acceleration. Part C then. This time we've got a bird that's starting about at B, so 680 meters away, and is flying back towards the train, and we want to find the point where they intersect. Well, our train distance equation is governed by this. We're given that at the start of the question. Our bird is traveling with constant acceleration, so we could use our Suvat equations here. We know s equals ut plus half at squared, and we know the initial velocity of the bird is -7, and it's traveling at 0.6 meters per second squared, but it's traveling back towards A, so that's a minus 0.6. But we have to remember that we're starting 680 meters away, so that's our formula. Now then, when the train equals the bird, when the distance from the train equals the distance from the bird, we can make those two equations equal each other, simplifying our equation for our bird. Collecting all the terms on the left-hand side, we've got a 25t and then add a 7t giving us 32t. We've got a minus 0.2t squared, add over that 0.3t squared giving us plus 0.1t squared. Bring over the minus 680 in our calculators, and an easy solve there to give t as minus 340 or 20. However, the domain of our initial equation has been restricted. T has to lie between 0 and 40, so t must equal 20 seconds. Right, we're not quite finished there. We need to find the distance from A. So part C continued. We know they're at the same point after 20 seconds, so we just need to substitute that 20 into one of the two equations, where the easiest one to do is to substitute our t equals 20 into our equation for the train. So we get s equals 25 times 20 minus 0.2 times 20 squared, giving us a distance of 420 meters.